Lesson 5-6, Parallel and Perpendicular Lines. Two distinct lines in a coordinate plane either intersect or are parallel. Parallel lines are lines in the same plane that never intersect. They also never touch. All right, so looking at these two pairs of lines, which ones are parallel? Hopefully you chose these two lines. Here's why. These two lines that keep going in this direction, since they're kind of kittywampus, they're going to eventually intersect at some point down the line. These two lines, however, are parallel because they will never touch. The reason they will never touch is because they have the same slope. Meaning, if this line goes up 2 and over 1, up 2 and over 1, up 2 and over 1, and this line goes up 2 over 1, up 2 over 1, up 2 over 1, their same slopes will allow them never to touch. So, if you looked at a y equals mx plus b equation, what do you think parallel lines have in common? They have the same slope. Their m in a y equals mx plus b equation would be the same. So let's look at this graph. Write the slope-intercept, that's y equals mx plus b, equation for each of the lines. All right, so let's start with the red line. I want to write it in this form. It's easiest to compare parallel lines. All right, my y-intercept looks like it's at 1. My slope is up 1 over 2. Y-intercept was 1. Okay? Now let's look at the blue line. Y-intercept is at a negative 2. Slope is up 1 over 2. Notice these lines are parallel because their slopes are both 1/2 or up 1 over 2. Their y-intercepts are different, but that's okay. That's what makes them different lines. If they had the exact same intercept, they would be the same line, okay? So it's okay to have different intercepts. We're just concerned about the slopes. So non-vertical lines, so lines that don't go up and down, oops, I want my highlighter, are parallel if they have the same slope and different y-intercepts. All right. For example, these are the ones we just did. These two graphs are lines that have the same slope of 1/2 and different y-intercepts, therefore they are parallel. All right, so we're going to practice writing an equation for parallel lines. So in a problem like this, they're going to tell you a line passes through this point and it's parallel to the graph of this line. What equation represents the line in slope-intercept form? So they always want these equations in slope-intercept form. So pretend that we're looking at a graph and there's already a line graphed. Its equation is y equals 2/3 x minus 1. We want to write a line for an equation for a different line that's parallel to this one and passes through this point. Well, it's actually pretty easy. Always start with point slope form. Even though we want to get to this form, point slope allows us to write an equation only knowing one point. So here we go. I have this point, and all I need to look at from this equation here is the slope. Since my parallel line will have the same slope, I know that this line will also have a slope of 2 over 3. So point slope form, y minus y equals slope times x minus x. There's my equation in point slope form. However, I want it in slope intercept form. So I'm going to first distribute, y equals, y minus 5 equals 2/3 x. And then we got to figure out negative 12 times 2/3 minus 8. Add the 5. Final answer, y equals 2/3 x minus 3. There is my equation of the new line that's parallel to this line. Hence, or notice they have the same slope of 2/3 different y-intercepts. All right, looking at these two lines. These two lines are perpendicular. You might have heard this before. Here's what it means. Perpendicular lines intersect, meaning they cross each other, and when they do, they form a 90-degree angle. So they cross exactly at a 90-degree angle. All right, let's write equations of these two lines to find out what perpendicular equations have in common. Let's look at the red line. Y-intercept of -1, slope up 1 over 2. That's for the red line. All right, let's look at the blue line. Y-intercept of 1, slope down 2 over 1, down 2 over 1. All right, now we compare these slopes. We have 1/2 and we have -2 over 1. Let's see what we have to say about perpendicular lines. All right, we already know they are lines that form right angles. Two non-vertical lines are perpendicular if the product, meaning multiplying, of their slopes is -1. Let's go back and see these slopes. If I have 1/2 and I multiply this slope, -2 over 1, -2 over 2, this equals -1. All right, it follows the rules that our book tells us. In other words, two numbers whose products are -1 are opposite reciprocals. So the slopes of perpendicular lines are opposite reciprocals, meaning if one line has a slope of 3, which we can write as 3 over 1, the other slope of the perpendicular line we'd flip the numerator and denominator and add a negative. These are opposite reciprocals. One more example, if I had -4/5 for one slope, its opposite reciprocal would be 5 over 4, the negative goes away. All right, so how do you know if something is an opposite reciprocal? They give you a slope, and you times it by its opposite reciprocal, it should equal -1. So, classifying lines are the graphs of 4y equals -5x plus 12 and y equals 4/5 x minus 8. Are they parallel, perpendicular, or neither? Explain. All right, here's the deal. Step 1, find the slope of each line by writing the equation in slope-intercept form. Oops, sorry, I don't mean to cross that out. So whenever they give you two equations of lines and they want you to compare them to see if they're parallel or perpendicular, we can't do any comparing until the equations are both in y equals mx plus b. So my first step, I always rewrite my equations. This one is already done. So that one's an easy one, I can just leave it. However, this one, 4y equals -5x plus 12. I need to do some work before it looks like this. I'm going to divide by 4, divide by 4, divide by 4. Y equals -5/4 x plus 3. So here's my equation of my other line. We want to know if they're parallel, perpendicular, or neither. Step 2, look at the slopes. If they were the same, it would be parallel. If they were opposite reciprocals, they would be perpendicular. If they didn't follow either of these rules, we would say neither. These lines might intersect but not form a 90-degree angle. So I have 4/5 for one slope, and I have -5/4. If I multiply this out, -20 over 20 equals -1. These slopes do indeed have an opposite reciprocal. I would say these lines are perpendicular. Here are some more examples. You can go back to the one I just did to see how to do it. Again, same slope, parallel, opposite reciprocal, perpendicular. If it doesn't follow any of these rules, the lines are neither. All right, Third example and final example, writing an equation of perpendicular lines. So we already wrote an equation of a parallel line, same slope. Now we want to write an equation where the slope is the opposite reciprocal. So first thing I need to do, here is the equation of the line that they want us to come up with a perpendicular line. It's going to go through this point. Again, we're going to use the point slope form. So I look at my equation that's already in y equals mx plus b. I see the slope of this line is 1/3. My slope for this line, since I know it's a perpendicular line, needs to be the opposite reciprocal of 1/3. Put 3 over 1 and I need to add a negative. So my slope is going to be a -3. Now I can use the point 2, 4 in a point slope equation. Y minus y equals my slope times x minus 2. Simplify. -3x plus 6. Add the 4. Here's the equation of the line that is perpendicular to this equation. My slopes are opposite reciprocals. All right, here's the lesson check I would like you to complete at class, or for class. Problem 1, which equations below have graphs that are parallel to one another? Which have graphs that are perpendicular to one another? So it's a multi-part question. Number 2, what is an equation of the line that passes through 3, -1, and is parallel to this line? Give your answer in y equals mx plus b form. And 3, what's an equation of the line that passes through 2, -3, and is perpendicular? Try your best, go back and watch if you have questions, and bring those questions to class.